So there are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. And the thing about the alkali metals is that they all react in a similar way. Elements in the periodic table are placed in the same group based on the number of electrons they have in their outer shell. Elements in group 1, all of the group 1 metals that we just talked about, have 1 electron in their outer shell. So they want to lose 1 electron to become stable, to gain that noble gas configuration. So they're all going to lose 1 electron to gain a 1 positive charge, so a 1 plus charge. Today we're going to be looking at the reaction of 3 alkali metals with the reaction with water. Now, we only look at the first 3 in terms of school because, as you'll see, the reactivity gets more vigorous as we go down the group. So the 3 metals we're going to be looking at today is lithium, sodium, and potassium. Now, these metals are all stored under oil, and that's because they all react with water moisture in the air. The first metal we're going to be looking at today is lithium. Now, what I want you to do with each of these reactions is to observe what is happening, so observe what you see. This is the kind of questions that get asked in exams, so observing what you see. So we're going to take the first metal, which is lithium, and I should point out that we're going to use tweezers for all of these reactions, okay, because we can't touch them with our fingers, as it would also react with the water moisture in our fingers as well. So I'm just going to take a little small piece of lithium out. I'm going to cut that. So, piece of lithium. Okay, so lithium is a grey metal. So I'm going to cut a small piece of lithium. Okay, so it's pretty tough to cut. Okay, so the size of the metal that we're going to use is pretty small. Okay, so just a little small piece of metal. So what we've got to do is, first of all, we have to dab off the excess oil, just using a piece of blue roll. Another thing that you should observe as well is that they tarnish when they're cut. So they're shiny when they're freshly cut, but they tarnish rapidly with air. So I'm just going to take a piece of blue roll and dab off the excess oil with the lithium. Okay, we have a trough of water here, so plentiful supply of water. And what I'm going to do is just take the lithium and with my tweezers and drop this into the water. So I want you to observe what is happening. Okay, so you can see that the lithium is moving along the surface of the water. There are bubbles of gas being produced. Okay, there's steam coming off, so there's heat released. It's disappearing at the end of the reaction, forming a colourless solution. So the next reaction I want you to pay attention to is the reaction of sodium with water. So I'm going to take a piece of sodium, and it's a little easier to cut. Okay, it's very, very shiny grey metal, but it does tarnish rapidly with air. Okay, so observe what is happening here with sodium. Here we go. Okay, so again, we can see that it's moving along the surface of the water, but also sodium is melting into a tiny ball. Again, bubbles are being released, heat is released, and again, it's disappearing at the end of the reaction. And you can see there that it took a shorter period of time to react. So we can see between lithium and sodium that sodium is being more reactive than lithium. So we're seeing already that there's an increase in reactivity as you go down the group. Now, the final one we're going to be looking at today is the reaction of potassium with water. Okay, again, it's stored in paraffin oil. So I'm going to take a small piece of potassium out and cut that. A grey metal. Okay, easier to cut. And hopefully we should see a nice reaction here with potassium. To potassium, we saw with sodium that it melted into a silvery ball and moved along the surface of the water. So we predict the exact same thing to happen here for potassium, although for it to be a bit more reactive. So observe what is happening. Okay, so we could see there that the potassium melted into a silvery ball, moved along the surface of the water, bubbles were released, heat was released, and it actually gave out enough heat energy to ignite. It's the hydrogen gas that is igniting with a lilac flame. So all of these group 1 metals are reacting with water, okay, to form the metal hydroxide and also hydrogen gas. So we could see there at the very end that the hydrogen gas ignited with a lilac flame. Another way to show that these alkaline solutions have been produced is to take a universal indicator. So if these metal hydroxides have been produced, we should see a dark purple or a dark blue colour being produced in the water. Okay, and we can see there that there's a deep blue colour of the water, indicating that an alkaline solution has been produced. So the question we need to be asking ourselves is, why do these group 1 metals become more reactive as you go down the group? So as we previously discussed, the group 1 metals all react in the same way, as their atoms have 1 electron in their outer shell. So when these metals react, each loses 1 electron to form a positive ion with a 1 plus charge. Okay, so if we were writing that in terms of a half equation, we're going to say X is our group 1 metal. It is losing an electron to become positively charged plus an electron. So why does the reactivity increase as we go down the group? So if we look at the electronic structure and the electronic configuration of these group 1 metals, as you go down the group, the reactivity increases. But what do we notice? As we're going down the group, the size of the atoms is getting bigger. Okay, so the size of the atoms are getting bigger due to there being more shells of electrons. And we need to remember that the nucleus is the positive part. So the nucleus is the positive part of the atom. And that is the attraction between the positive nucleus and the electrons in the shells. So the further away that we go from the nucleus, the easier it will be to remove the outer electron, because it's held less strongly. So the further you move away from the nucleus, the easier it is to remove the outer electron. Therefore, more reactive. So that's why we're seeing, as we move from lithium to sodium to potassium, the reactivity increases, because as you move further down the group, the outermost electron is further away from the positive nucleus, therefore easier to lose, therefore more reactive.